We are right on the edge of a massive, fundamental shift in how we power our entire world. And I'm not just talking about putting up a few more solar panels or wind turbines. We're talking about some truly next-level stuff, like replicating a star right here on Earth, drilling down to tap the planet's own heat, and inventing solar cells that just completely shatter all the old efficiency records. So let's dive into this new energy race.
It really all kicks off with this one number, 79%. Just think about that. That's how much more electricity the world is expected to need by the year 2050. It is a staggering jump, and it's driven by everything: rising living standards, a tidal wave of electric vehicles, and, well, the electrification of just about everything. But there's a new player in town that's pouring jet fuel on this fire: AI. The absolutely massive data centers that you need to train and run these advanced AI models, well, they're creating this enormous, frankly unanticipated hunger for constant, reliable power. And this, right here, is the heart of the problem. It creates what you could call a massive electricity gap. Look, as much as we all love wind and solar, their big weakness is that they're variable, right? They depend on the weather, on the time of day. They are absolutely essential, for sure, but they just can't plug this gap all by themselves.
So, that brings us to the trillion-dollar question. How are we going to close this gap? How do we possibly meet this incredible new demand with clean energy that's there for us whenever we flick a switch?
To answer that, we are going to look at 3 absolutely incredible emerging technologies. Now, it's really important not to think of these as competitors who are all fighting for the top spot. It's much better to think of them as a team, a portfolio of specialists where each one has a unique and critical role to play. So, on our team, we've got 3 main players. First, the big, ambitious one, nuclear fusion. This is the ultimate prize, right? Limitless, clean power. Then you've got the workhorse, next-generation solar, which is set to make solar power way more efficient than it is today. And finally, you have the unsung hero, enhanced geothermal, the reliable foundation that can pump out power 24/7 pretty much anywhere on Earth.
Okay, so let's get into the details. We're going to open up the playbook for each of these and really understand how they fit together to build the power grid of tomorrow.
Now, before we get any further, there is one concept we absolutely have to get our heads around. It's the difference between intermittent power and firm power. So, intermittent sources, like your typical solar panel, they're variable. But firm power, that's dispatchable. That means you can turn it on and off whenever you need it, on demand. And that quality is probably the single most important thing for keeping our grid stable. It's what makes our other 2 contenders so incredibly valuable.
Let's start with what's called enhanced geothermal systems, or EGS. For decades, geothermal power was kind of niche, It was limited to places with natural hotspots, like Iceland. But EGS changes the game completely. It's a technology that's designed to unlock the Earth's natural heat from hot, dry rock, which, it turns out, exists almost everywhere.
So how does this actually work? Well, it's pretty brilliant. It actually borrows a lot of technology from the oil and gas industry. First, you drill wells, way down. Then, you pump water down at high pressure to reopen and connect a whole network of tiny existing fractures in the rock. Finally, you just circulate water through this new human-made reservoir. It absorbs the Earth's heat, creates steam, and that steam drives a turbine, 24/7.
And here is the number that makes investors and governments really sit up and pay attention: $45 per megawatt hour. That's the target the U.S. Department of Energy has set for 2035. And just to put that in perspective, that would make enhanced geothermal cheaper than natural gas in a lot of places. I mean, we're talking about a cost-competitive source of clean, firm power.
Okay, let's move on to the next player on our team: next-generation solar. We're all familiar with solar panels, but the silicon technology that we use today, it's kind of approaching its physical limits. The next big leap forward is coming from a whole new class of materials that could totally revolutionize the industry.
The key innovation here has a fancy name: the perovskite on silicon tandem cell. But the concept is actually brilliant. You take a normal silicon cell and you add this super thin, semi-transparent layer of a material called a perovskite right on top. So the perovskite layer grabs the high-energy light, like blues and greens, while the silicon underneath grabs the lower-energy reds. It's like a perfect 1-2 punch for capturing sunlight.
And this chart just shows you the result. Your standard commercial panels, they kind of top out around 22% efficiency. But in the lab, these new tandem cells have already hit a mind-blowing 34.6% efficiency. That is a massive leap forward. It means we can get way more power out of the exact same amount of space.
And that brings us to the ultimate prize, nuclear fusion. For decades, this has been the holy grail of energy, right? The idea of harnessing the exact same process that powers the sun to create clean, safe, and pretty much limitless energy right here on Earth.
Now, the challenge with fusion is just immense, and it really boils down to something called the triple product. You have to get three things right all at the same time. You need insane temperatures. We're talking over 100 million degrees Celsius. You need enough density so that the atoms are actually likely to bump into each other. And you have to hold it all together for long enough to get a sustained reaction. No big deal, right? So, let's put it all together on this scorecard. First, just look at that dispatchability row. See? Solar is intermittent, but geothermal and fusion are firm. That's the key difference we talked about. Now, look at the cost. Solar is projected to be the cheapest, but you can't always count on it. Geothermal is right there in the mix, and it gives you that crucial firm power. And then, check out the land footprint. Solar takes up a ton of space, while geothermal and fusion are incredibly compact. You can really see how they all have different strengths. But here's the thing. This race is about so much more than just electrons and technology. The nations that figure this out first, the ones that lead in developing and deploying these energy sources, they're going to gain huge strategic advantages. It's going to reshape the global balance of power for the whole 21st century.
Just take a look at this chart. It's staggering. China controls 97% of solar wafer production. Let that sink in. This isn't just a big market share, it's a near total monopoly on a critical piece of our clean energy future. And that creates massive supply chain risks and some serious geopolitical vulnerabilities.
But this is where that next-gen solar becomes a huge strategic game changer. See, manufacturing perovskites uses different materials, and the factories aren't as crazy expensive to build. This could potentially shatter that monopoly, lower the barrier to entry, and let countries all over the world build their own domestic solar manufacturing. It could democratize the whole thing.
And the stakes with fusion? They're even higher. We're talking about a projected trillion-dollar market. The first nation to get commercial fusion up and running will achieve true energy independence, completely freeing itself from the crazy ups and downs of global energy markets. So it's really no surprise that the US and China are now locked in this fierce race for the lead.
So the most important point is this. We're not looking for a single winner to rule them all. What we're actually doing is architecting a brand new kind of grid. It's an integrated system where these technologies all work together to create something way more resilient and reliable than anything we have today. So just picture this grid of the future. You've got next-gen solar acting as the workhorse, flooding the grid with ultra-cheap power whenever the sun is shining. Then you have enhanced geothermal as the bedrock, the reliable foundation, that constant 24/7 pulse of clean power that never ever sleeps. And then fusion is the ultimate scalable powerhouse, like a miniature sun you can deploy anywhere to power our biggest cities and our most power-hungry industries.
You know, this isn't science fiction anymore. These technologies are real, the investment is pouring in, and the geopolitical stakes are absolutely immense. A new energy era is dawning right now. The race for the 21st century is on, and the only question left is, who's going to cross that finish line first?